Hello, this is the video for the data mining course, and I'm going to continue the lesson about data pre-processing in the second part. So the last video, we already discussed about the data pre-processing, about the, the data reduction, and in this video, I would like to discuss about the data transformation. What is data transformation? Based on the definition, it is a function that maps the entire set of values of a given attribute to a new set of replacement values. So subject to each old value can be identified with one of the new value. So the key point is how can we transform the old value to new values. There are many ways to transform the data. You can do the smoothing. So smoothing means we want to remove noise from the data. And we can also do something related with the attribute or feature construction. So you already learned from the previous video that we can also construct a new attribute, and those new attribute will contribute to a new value. So you don't need to use the old values, just use the new values. Or we can do the aggregation. So the aggregation means like the summarization, data cube construction. So we will learn those things as well. There is also another way to do the data transformation by normalization. So normalization means I want to scale to fall within a smaller or specified range. So there might be some ways, and in this video, I would like to explain 3 ways for the normalization: min-max normalization, z-score normalization, and the normalization by decimal scaling. The other kind of data transformation is related to the discretization. It can be related to the concept hierarchy climbing. So I'm going to explain about the way to do the normalization. In the basic normalization, mostly are related with the min-max normalization. In the min-max normalization, we need to design what is the new minimum and what is the new maximum. Let's say I have income. Okay, just want to explain the example instead of the formula. So if you can see this one, v prime is the new values. Okay, and v is the current values, and we want to subtract with the minimum of that values, and then divide it by the maximum minus by the minimum. And we need to do one more process to deal with the new maximum minus the new minimum plus the new minimum. So suppose we have the income range. Okay, the income is between 12,000 US dollar and 98,000 US dollar. So the range is very big, between 12 until 98. And I can say that this is the minimum. Okay, this is the minimum, and the other value is the maximum. Okay. Now, if I see this one, then you need to find out what is the new minimum and what is the new maximum. Suppose I have the new minimum is 0 and the new maximum is 1. So I would like to change the 12,000 into 0, and I want to change the 98,000 into 1. Then if I have a value 73,000, what is the new value? Okay, then I can just put the formula here. 73.600. Oh, sorry. I think this one should be 0. Okay. So, yeah, you can. I think this one is still using the 600. Okay. So this 73,000 minus 12,000 divided by 98,000. This is the maximum minus the 12,000, and then we have the maximum, the new maximum, and then this is the new minimum. Okay, this is the new minimum, and plus the new minimum, this is 0, and we got this value. So this is the value, or this is the new value to indicate this income. Okay. The other way to do the normalization, we can use the z-score normalization. So if you still remember in the our previous chapter, we discussed about the set score. The set score is also one way to do the normalization. We use the mean and the standard deviation to normalize the values. Let's say this is the new value, and this is the old value minus by the mu, which is the mean, and the standard deviation. Let's suppose I have the mean is 54,000 and I have the standard deviation is 16,000. And let's suppose I have the value of the income. Yeah, this is just giving the example of the income. 73 $600. I will just minus with 54,000 because it is the mu, and then divided by the standard deviation 16,000, and I will get this value. Okay, so this value will be the new value based on the set score normalization. Last one for the normalization method is about the decimal scaling. So the decimal scaling is you are to put the value, the new value is based on the v divided by 10 power of j. Okay, so what is j? J is the smallest integer such that the maximum of a value is less than 1. Okay, what does it mean? Let's see one example. Okay, so based on the definition, we have the j is the smallest integer such that maximum v prime is less than 1. So I would like to find the best j. Okay, the best j to indicate the value that is less than 1. So suppose we have this input data, minus 10, 201, 301, minus 401, 501, and until 701. If you check this data, first, okay, I want to normalize the data. How can I normalize this data? First, I need to get the maximum absolute values. The maximum absolute value is 701. Okay, this is the maximum. And then the step 2, I need to find the j until it satisfies the condition. Okay, so I need to find what is the maximum. So the maximum is 701, and I need to find what is the best j that the value of the v prime. So the v prime here, okay, is the new value such that it is it will be below 1. So I need to iterate. Let's suppose j equals to 2. What if j equals to 2? Then the 701 divided by 100. And the value is 7.01. Is it less than 1? No. Okay. So this one is no. Let's go to the next j. J equals to 3. Okay. So if I divide 701 and divided by 1000, then the value will be 0.701. Okay, then this is less than 1. So I will choose j equal to 3. Okay, and it will be the value to divide all the input data. Okay, so all the input data will be divided by 1000. So the result of the normalization will be this value. Okay, because every value will be divided by 1000, 1000, 1000, 1000, and 1000. That's about the normalization. And if we are dealing with the discretization, so the discretization means we want to deal with some basic attributes. Okay? You know, the basic attributes, categorical and the numerical. The discretization can be regarded with the nominal. Okay? The nominal is the values from an unordered set. So for example, color, profession. So you can discretize the color, or you can discretize the profession. For example, the profession is professor. So professor can be the full professor, associate professor, or assistant professor. Okay, so those attributes, it can be discretized again, or it can be categorized. So the ordinal, it means we have the order set. So the military or academic rank, we can also discretize this one. And numerical. In the numerical, it will be very challenging because it is a real number, or it can be integer or real numbers, and we want to discretize it. So the discretization means we want to divide the range of a continuous attribute into intervals. So this kind of way is we want to do the labeling. It means we want to put the label to replace the actual values. For example, what is your age? If I say that, okay, my age is 25, okay, then it's difficult to say that about this age, okay, you're 25. But if I say that you are young, okay, then it will be something related with the label. So this is the interval label. Okay, I can say that someone who are in the 20 until 30, I can say they are young. Okay. So that's the meaning by interval label. Reduce data size by discretization. Yeah, if you are having a lot of data, then if you just put the integer number like 25, 28, 29, yeah, it might be a lot of ranges. So using the labeling, like only young, it will give a benefit for you to reduce data. There will be other way like supervised and unsupervised. So we will discuss this one in the later part. And also split or merge. So you can top down or bottom up. Yeah, we will also discuss this one. Discretization can perform recursively on an attribute. So we can also try to do the recursive according to the values, and we can find the best way to discretize. And there can be other way like classification. The methods to deal with the data discretization mostly are related with those stuff, but it can be extended to other kind of methods. Let's say pinning, okay? It means I want to split from top to down. Okay? Histogram analysis also a kind of top-down split, and it's from top to down. Clustering analysis, it is unsupervised. Okay? So I will discuss this unsupervised. What is unsupervised? You will learn it from the later part. Okay? And we are dealing with the top-down or bottom-up. Okay? Those two can be done with the clustering analysis. And the decision tree analysis, yeah, this is about the supervised and mostly is top-down. Correlation analysis or chi-square analysis, you already learned about this one. So it is unsupervised, because there will be no labeling from the first part, and it is like merging or bottom up. Yeah. In the simple discretization, we can just do the binning. Okay. The binning means we want to divide or we want to partition based on the width or the distance. Or we can partition based on the depth or the frequency. Okay, so if we are dealing with distance, means we want to divide the range into an interval of equal size. We call it, this is uniform grid. So let's say I can just use this one. W is the width equals to B minus A divided by N. So the A and B, yeah, A is the lowest and B is the highest values. I will show with the example later. So this is straightforward, and outlier may dominate presentation. And skew data is not handled well. Just remember the skew data. So if we have the, this one is skewness over the left, and then if we have this kind of data, the skewness is on the right. Okay, so with the equal width, the skew data is not handled. So there is another way to do the partitioning with pinning. We can say about the equal depth or frequency. So in the frequency wise, we can divide the range into n intervals, and it's containing approximately same number of samples. So the number of frequency for each binning should be at least the same. Okay. And it is good data scaling, and it can, later on when we have this binning, how to give the categorical attributes. So that will be very tricky for this one. So let's see one example. I have this price, okay, and this is already sorted. Okay, this is already sorted data. It means this already in the from small until the largest. So if I want to use the equal frequency or equi-depth, what does it mean? I know that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 data, and I want to make 3 bins. How can I make 3 bins? Then I can just divide the frequency into 4, 4, and 4. Okay. Then the bin 1 will be 4, 8, 9, 15. So the first 4 value. The bin number 2 will be 21, 21, 24, 25. So the next 4 numbers. And the bin 3 will be 26, 28, 99, 34. So there will be the 4 last number. This is how to do the partition. How if you want to do smoothing? Smoothing means you want to change the value into a new relevant values. Because I think the range is diverse, you may want to give smoothing values. Let's say in the bin number 1, I think that, this is an example, okay? If I want to do the smoothing by the bin means, what is the bin means here? So here 4 plus 8 plus 9 plus 15 divided by 4. Then it will be 9, okay? So 12 plus 24, so 36, okay? 36 divided by 4, because we have 4 value, then the result will be 9. So the 9 will replace each of the value in the bin, because we are going to use the means. How about if we use the boundaries? If we use the boundaries, means we want to see the minimum and the maximum values. In the bin 1, what is the minimum value? Okay, the minimum is 4. So if the value is 4, okay, that's 4. What is the next value? The next value is 4. Why? Because 8 is closer to the minimum or maximum. Yep. Yeah. 8 is closer to 4. That's why we just give number 4 for the smoothing. What about the next? 9. 9, which is closer? Minimum to 9 is closer to 4, or 9 is closer to 15. So we know that 9 is closer to 4. Then we just put the 4 as the smoothing value. And 15, okay, yeah, we just put 15. What about bin number 2? Yeah, it's also the same. 21, 21, 25. Yeah, you can see 25, 34 is the value which is closer, minimum or maximum. So we know that 24 is closer to 25, so we just put the 25. Okay. So this is the smoothing by bin boundaries. Now, what is the meaning by equi-width? What is equi-width? Okay, if we have this one, okay, it is based on the distance. So we need to apply this equation. W equals to B minus A divided by N. What is B? Here is the maximum. Okay, 34 is the maximum. And what is the minimum? 4. Okay, and I want to divide into 3. So the division will be 3 and the result is 10. Okay, what is 10? The 10 will be the distance. So I know that the minimum is 4. And let me have 10 values. So 4 until 13 is already 10 values. And then next it will be 14. And 14 will be the next 10 values. So it will be until 23. And the 24 will be the next one. And we will have 34 as the last values. Yeah, because we want to divide only 3. So 34 should be included in the last one. Therefore, we can check where is the position of 4. 4 is here, then we can put here. How about 8? 8 is here. 9? 9 is also in the pin number 1. What about 15? Okay, 15 is in the second range. Then we can put the 15 in the pin number 2. 21 is in this range. Then we put in the pin number 2. Pin number 3 is the remaining because it starts from the 24 until 34. So this is the result with equi-width. And yeah, you can also do the equi-width. After you have this value, you can do smoothing. Do you want to smoothing with means, or you want to do smoothing with boundaries? That's also fine. Okay. So the discretization between binning and clustering. So if you are doing with binning, you need to find the best way, whether you want to use width or frequency. Okay. And if you are dealing with clustering, it may give you better results. Okay, so we will learn about this clustering later, and hopefully that will be also helpful for you to understand how to discretize the values. We can also do the discretization by classification or the correlation analysis. In the classification, we will learn about the decision tree analysis. Let's say I have the class labels. I can say this is the supervised learning. Supervised means I know the label. I know what I'm going to do. I know that I'm going to figure out between the labels or something that we want to decide. So if I know this figure, if I know all the features, okay, if I know the size, I know the color, and I know the any other thing from this one, so I can distinguish whether it is a cancerous or benign. So benign tumor or malignant tumor. Malignant tumor means this is the tumor which is dangerous, or we can say this is cancerous. So it is the root of cancer. And the benign tumor is just a tumor. It's not dangerous. So the result is like the top down, and okay, we will discuss this one later. Or we can use the correlation analysis, you know, about the chi-square. Okay, the chi-square is also supervised. We can use the class information, and then we can find the best neighboring intervals. If we have the similar distribution of the classes or low chi-square values, then we can merge it. Okay? If the chi-square value is high, then yeah, you don't need to merge. We can also do the merge with the recursive until some kind of condition is satisfied. So those kind of things, yeah, can be done also for the discretization. The other way to do the transformation is to deal with the concept hierarchy. In the concept hierarchy, we want to know the hierarchy, and usually associated with the dimension in the data warehouse. So what is data warehouse? We will learn in the next section. In the concept hierarchy, usually it facilitates at least two things, okay, drilling and rolling. So drilling and rolling, see this is an example. Okay? If we are dealing with the roll up, it means I want to go to the higher level. New York, Chicago, Arizona, there is the city in the USA. So if I want to do with the transformation, I just use the higher level, or this is the roll up. From the low level, I go to the higher level. Let's say, you know, Seoul, Busan, Daegu, Daejeon. They are cities in Korea. So I want to find the higher concept. It is Korea. Okay. Or if you want to say something about our society, okay, in Yongin, we live, okay, in Choin-gu, and then there is also another gu, Suji-gu, and also there is another gu, which is Gyeonggu. Okay, so if we combine the Choin-gu, Suji-gu, and Gyeonggu, the higher level will be Yongin City. Okay. The drill down is the opposite of the roll up. Okay, so the drill down, we want to make it a detail. Okay. So in the drill down, it means I want to have, for example, Q1 is quarter one, and in order to find out the detail, I just want to make a more detail like January, February, and March. So those are the details of Q1. For the Q2, it is the detail of the April, May, and June, and so on. If you know those concepts, then we can adjust whether we want to use the higher hierarchy or the lower hierarchy. And this concept hierarchy formation, it will recursively reduce the data by collecting and replacing low-level concepts. So the low-level concept like January, February, March, I know that this belongs to the Q1. Okay, so I just want to use the hierarchy concept. Then you can transform it. There's another concept for the nominal data. Okay, so for this one, there are several concepts. If you're dealing with the numerical values, then you can have like the discretization. If you are dealing with the nominal data, the nominal data, there are some things that you need to understand. Let's say we want to do the concept hierarchy based on the schema. Let's say I know the street is the smallest one, and after the street we have the city, and then after the city we have the state, and then after the state we have the country. For example, we are in the Wedero. Okay, Wedero is street, and then in the upper part of the Wedero is we have city, Yongin city, and then after the Yongin city we have the state, which is Gyeonggi province. After the Gyeonggi province we have the highest one, which is the Korea. We can do the hierarchy for a set of values by exploiting the data grouping. Let's say the Urbana, Campaign, Chicago, it is belong to the Illinois state, for example. So it's also the same in, I think in Korea, like what I mentioned before. Okay? We have the maybe Sujigu, okay, Cheongu, and Gihanggu. Okay, they are a set of values in the Yongin city. And for the specification, only a partial set of attributes. We have 4, okay, we have this definition, but I do not want to use all. So I just want to use only street and city. Yeah, that's also fine. So we just limit the number of data. Or we can do the automatic generation. Okay. When we do the automatic generation, it means we collect all the data and then we put the data into the analysis, and the analysis will be counting the number of distinct values. So let's say I have a set of attributes: street, city, state, country. Okay, for example, I have the Wedoro, Yongin, Gyeonggi, Korea. And then I have another row, Wangdam-ro, Yongin, Gyeonggi-do, Korea. Okay. Or I have another street name, for example, Gangnam-ro, Teheran-ro, Seoul, and then the state is okay, Seoul, and then Korea. So if we collect all the data, okay, so if we have the first data, we have the second data, we have the third data, we have the fourth data, and we have the collection of the data, so we can do the automatic generation of the hierarchies. So the automatic concept generation means we want to do the automatically generated based on the number of distinct values, which is the unique values. If I know the unique values, there are 15 distinct values per country. Okay, there might be a lot of more distinct value in the province or state. There will be a lot of more distinct value in the city, and there will be a lot of more distinct value in the street name. Okay. This one is good for place like this one, but not good for time. Okay, because in the time you already fix. Okay, it means you know already, and in the 1 year there will be 4 quarters. In the 4 quarters there will be 12 months. In every week we have how many weekdays? 5 days, for example. So this is exception. So you don't need to use the automatic concept hierarchy generation in the time because it is already fixed. We already know the idea. Okay, this is the learning check. Okay, what is discretization? Okay, so learn from the basic definition again. What is discretization? So you learn about the discretization here. Okay, divide the range of continuous attribute into intervals. Yeah, and then can you mention some of the data discretization methods? Okay, we have like 5. Okay, we have the binning, and then we have the histogram analysis. Yeah, and then we can also do with the cluster. We can do the decision tree analysis, and then we can do with the chi-square. Do you know the difference between equal width and equal depth? Okay, first is the equal width is based on the distance. That's right. Okay, so this is based on the distance. And what about equal depth? Equal depth, it is based on the frequency. That's right. Okay, so you can see this one. Yep, the equal depth is based on the frequency, and then the equal width is based on the distance. And then what is else? We have the concept hierarchy generation. There are 2 concepts, drill down and roll up. What is the difference? Yeah, drill down, we want to find the lower one, the lower hierarchy, and then roll up, meaning I want to know the higher hierarchy. Okay, that's easy, but you need to understand that one. So that will be some of the question for the quiz and also your exam later. So I will use the other video to explain about orange, and I will end this video. See you in another video.